What if I told you that giant clams can help solar panels be more efficient? Imagine that. A clam, a thing that sits in the ocean, has beautiful colors around it. It has purple, blue, green, yellow, like just very, very bright fluorescent colors. Stands could be like 4 meters wide, 4 meters long, however you want to measure it. Looking amazing. And I'm telling you that this clam can actually help solar panels become more efficient and help in the increase of renewable energy to be able to meet our energy needs globally. What if I told you that? Would you believe me? I wouldn't. At first I'd be like, no, I don't think so. I don't see the connection. But it has to do with algae that sits in these clams that allows it to absorb sunlight and allows the algae that actually uses the sunlight to be able to flourish. And that's going to help, the way that it's arranged, that's going to help the solar panels become more efficient. We're going to talk about that on today's episode of the How to Protect the Ocean podcast. Let's start the show. Hey everybody, welcome back to another exciting episode of the How to Protect the Ocean podcast. I'm your host, Andrew Luan. This is the podcast where you find out what's happening with the ocean, how you can speak up for the ocean, and what you can do to live for a better ocean by taking action. And this is the place, if this is the first time you've been here, we're on YouTube now, we're on Spotify video right now. We also have audio on Apple Podcasts, Spotify, and so forth. But if this is your first time or you're new as the first couple times and you haven't checked out our website, please do. Speakupforblue.com is where you go to find out all of our podcast episodes, our YouTube episodes, all of our podcasts, like other podcasts that we have, Beyond Jaws and just Aqueducts. It's just a bunch of different ones that we have that are very good for you to be there. And of course, we also have information that is sent to you through our newsletter. So if you want to get that sent right to your inbox Monday to Friday at 8 a.m. Eastern every week, you can do so every day of the week. You can do so by going to speakupforblue.com/newsletter. That's speakupforblue.com/newsletter and check out what we have. We send news, we send job ads, we send our videos and updated podcasts and so forth. It's a lot of fun. Check that out. Speakupforblue.com/newsletter. Let's talk about clams right now. Now, this is probably not the clams that you're thinking about, not the edible clams that you would get on a plate when you go to a seafood restaurant and you pay a lot of money for, or you go to your seafood dealer or your seafood supermarket and you're like, hey, you know what? I want clams. You get these little clams that come in and you eat them and they're delicious, and especially if they're grown sustainably, they're very good. This is a different type of clam. This is like one of my favorite species of all time. I'm a big invertebrate guy. I'm not sure if you've noticed that. Cuttlefish are a big thing of octopus. I'm very interested in these types of species. They really make me, happy. They make me happy. And clams, giant clams, are really important in coral reef areas, especially in the Southeast Pacific. These things are massive. These things are not only live animals, but they also act as, in the picture that I'm going to show you, act as a coral reef. They have corals living on their shell. They're a hard shell coral. They require calcium, and they have this fleshy inside that shows these beautiful colors that kind of come out. So as the clam opens during the day, and when it's healthy, it'll come out with this like soft tissue, and it'll just come out. It almost looks like a flower, but it's like this neon blue, green, purple, yellow, different types of colors that just kind of show. And what it does is it actually sits there and it does two things. One is it grabs sunlight. And this is what we're going to be focusing on today, but it grabs sunlight, but it also filters in other organisms, like filters in plankton and to eat. And it goes through a siphon and it comes out. And so it helps clean the water. Now, I used to be a marine aquarium hobbyist. I loved being a marine. I loved having the reef in my house, like having an aquarium. I don't do it anymore because I can't spend as much time. I also worry about importing animals and where they're coming from and so forth. It became really difficult. I felt bad if something died, and so I stopped doing it. However, one of the things I used to fall in love with was giant clams. Giant clams were the best. They're still the best. I would love to see them. I've never actually snorkeled in the Southeast Pacific where they're found. I would love to go see them. They would be an amazing, bucket list item for me to go see them. Not sure about you. I'd love to hear your bucket list item in the comments below, but these things are gorgeous. And I remember having them in a tank as part of my coral reef. And I used to have to feed it, almost like by a little pipette, and you'd have to feed it plankton. And so I'd grow my own plankton, or I'd buy plankton that was grown from a lab, and I would go in and I would squirt it in. I have to directly squirt it in. These are not easy species to take care of. If you are a marine aquarium hobbyist, you need to be almost in the advanced category to be able to take care of them properly to make sure they're healthy. You need the right lighting and you need the right plankton to actually feed them. They will clear up your tank, especially when you first get them. That's the one really realize when you first get a coral reef tank and you get these types of corals that really siphon in and these clams that really siphon in and take out all the plankton in your water. If you have cloudy water that has a lot of organisms in it, that will kind of clear up that water. It's really kind of cool to see. Plus, it brings in more sunlight. So if you have lights, it'll bring in more light to the corals as well as the clams. Now, the way that clams work, as I mentioned before, is you feed them manually with plankton, or they use sunlight. Actually, both. They use sunlight. They absorb sunlight so that their zooxanthellae, their actual algae cells that actually live within the soft tissue of the clam, grab light to allow those algae to live and probably bring off some calcium, build up their calcium shell. So they need that light. To be able to absorb that light, they need to kind of go out of their shell, open up their shell, and that soft tissue gets it. And that's why you see the colors that you actually see in these giant clams. If these organisms aren't there, if this algae is not there, the species will eventually die. It's kind of like a bleaching coral in a way, but the tissue will deteriorate, the clam will die, and it won't be able to eat anymore, won't be able to function. The interesting part of this is getting into the solar panels. Solar panels right now you worry about the efficiency. I think, according to this article that I found in Animals Around the Globe, I think the efficiency was about 60 some odd percent, I think is what it is, 67%. Not the best efficiency, but not terrible. The interesting thing is the corals only reflect 5% of that light away from the organism. So that means it absorbs 95% of the light. So the efficiency is a lot better, increased by 30%, than the solar panels that are now, the common solar panels that you have now. Now imagine if you can duplicate the efficiency in the clam, the giant clam, and put it in a solar panel where you can get more from each solar panel. Wouldn't that make it a lot better? Especially when we're trying to solve our energy crisis, especially when we're trying to divest our infrastructure of fossil fuels. This would be really cool. So the way that they looked at it, they did like a lab analysis. They looked at how the algae were arranged within the fleshy tissue of the giant clam. They were arranged in a line, and that made it a lot easier to be able to absorb the sunlight. Then once they can absorb the sunlight, they use that sunlight and they incorporate it into the body, and they feed off of it and so forth. They use photosynthesis. Imagine if you're able to duplicate that formation and put it on solar panels. Once you're able to do that, the solar panels are able to thrive. They're able to increase their efficiency. The other thing that they're looking at is the type of algae that's there. Are they optimal for doing this? Can they be replicated into solar panels to make sure that the compounds that actually absorb the light from the algae cells, can they be duplicated and can they be added to solar panels to increase the efficiency of these solar panels? Here's the kicker. We found this out from a giant clam. I asked you before, if I said that we can increase the efficiency of solar panels by looking at giant clams, I asked you if you would believe me. Some of you are probably like, no, I don't even know what this guy's talking about. This is crazy talk. I thought the same thing. But imagine now if we didn't have giant clams, if we didn't take care of our coral reefs properly and we didn't know about these giant clams. This is why we are, like, scientists are always talking about protecting biodiversity, protecting as many animals as possible, because you never know what we're going to learn from these animals. Like, we protect sharks, not only because they're an apex predator and they regulate the food web, but also because they have a lot of properties that have helped us in cancer research. These animals are important to our own health. We've looked at how animals regenerate, like starfish, like corals, and so forth, and we looked at the compounds in there and how we can help in terms of growing cells, in terms of growing organs. There are a lot of different things that you can get from the ocean that will help us in pharmaceuticals. We know horseshoe crabs have this, like, coagulant in their blood that's used for vaccines. There's a lot of things that benefit us that are in the ocean, but if we don't protect biodiversity, we don't know what we're going to miss. And you're probably like, well, yeah, well, if we don't know what we're going to miss, well, we don't know what we're going to miss. It's no big deal. What if we can cure the next big disease that comes in? What if we can cure more cancers? What if we can cure more diseases that affect us, or be able to, fortify our vaccines and our other medicines that will help us in recovering from these different diseases that we face, whether they be new diseases or whether they're old diseases. The modern medicine is based off of what we notice and observe and replicate from nature. Ocean has a lot of biodiversity. We are doing a very terrible job in protecting that biodiversity, because every time we talk about biodiversity, people are like, whatever, it has nothing to do with me. At least with climate change, when we say we got to protect the ocean because it helps us regulate climate change and reduce climate change, at least we know there's like a direct effect. If we reduce climate change through the ocean or protect the ocean to help reduce climate change, we know that we can help. If we want to make sure there's enough algae in the water, we want to make sure the water quality is good enough, we want to make sure that we're protecting species and protecting habitats that allow us to develop and protect these natural processes that allow carbon dioxide absorption and methane absorption and not the release of these greenhouse gases. That is a little easier to understand for people to say, hey, you know what? Yeah, we need the ocean. It's every second breath is because of the ocean. But a lot of times when it comes to biodiversity, I see people, they just glaze over. They're just like, I just don't get it. Like, yeah, we want to protect species. We want to make sure that the animals are safe, they're well for the animals are good, and we protect them. But what do we really need them for? Like, if we lose a species, is it that big of a deal? Who knows, right? I think it's a big deal just to lose a species. The extinction rate of species is crazy, but we still need to protect everything because we don't know what we're missing. We don't know what we're going to miss out on. The next species that goes extinct could save part of humankind. And I know some of you are just like, well, yeah, but there's too much of us anyway, but we still need to help people. It's still in our blood. It's still what we do as a human species, help as many people as possible. To do that, we need to protect biodiversity like giant clams. Protect those species because they will help us become more efficient in absorbing light and absorbing solar energy to help our energy needs and help divest us away from fossil fuels, dirty fossil fuels like coal, oil, gas, all that kind of stuff, and get us back into renewable energy, get us more sustainable, and still be able to fill the energy needs of today's world, because we need a lot of energy. And so biodiversity is a big deal. Protecting biodiversity is a big deal. It should be important to you. It's important to me. It should be important to everybody. And we need to get that across by highlighting stories like this. Giant clams are extremely important. And so I wanted to highlight it with you. I wanted to highlight the fact that we need to protect biodiversity and that giant clams are super cool and you need to know about them if you haven't known about them before. And if you're ever in the Southeast Pacific and you're able to dive and to snorkel on these animals or within these animals, don't touch them, they're very sensitive, but be able to see them, I hope you do, because that is on my bucket list and I hope it's on yours as well, at least now anyway. But love to hear your thoughts on these giant clams and how they can make solar panels more efficient. The story, I'd love to hear your thoughts on solar panels, and if you're an engineer or something like that, and you want to talk more about solar panels and how they can help the ocean, please feel free to reach out to me at How to Protect the Ocean. That's all one word, How to Protect the Ocean on Instagram. But don't forget, you can follow us, subscribe to us on Spotify, YouTube, Apple Podcasts, any of your favorite podcast apps. You can get access to us just by subscribing or following and hitting that notification bell. And I want to thank you for joining us on today's episode of the How to Protect the Ocean podcast. I'm your host, Andrew Luan. Have a great day. We'll talk to you next time, and happy conservation.